Hello everyone, welcome to Vihari Academy. In our previous session, we have discussed about different types of coordinate systems that are linear and curvilinear coordinate systems, and we discussed how we can derive relationships between linear and cylindrical coordinate systems and linear and spherical coordinate systems. And now in this session, we are going to relate cylindrical and spherical coordinate systems. Let us see how we can do that. So now we are going to form relationship between cylindrical and spherical coordinates, so that we are going to define cylindrical coordinates in terms of spherical polar coordinates. R is 2D and rho is 3D representation of position vector. So now if we have a point Q in both cylindrical and spherical coordinate systems, we can define like this. And now let us suppose that the position R is defined with inherent x and y transformations from origin, like x and y, and this is a vertical displacement z, this is theta, and if we write in spherical polar coordinates, it will be rho. I mean the position coordinate will be rho. So now from this we can form a triangle as R as the base and Z as opposite side, and here is the rho. This is the right angle triangle, so according to Pythagoras law, we can write rho as square root of r square plus z square. And theta will be same in both the coordinate systems, so that we have no change in theta. And now if phi is there as an angle between rho and z, then we have to write the cosine form of phi as z divided by rho, which is adjacent side divided by hypotenuse, which in turn can be written as z by square root of r square plus z square. Now let us write r theta z in terms of rho theta phi. Here is the r, this is x and y, this is z, here is the angle phi and azimuthal angle theta. Now we can separately draw the right angle triangle, which is formed by r, z and rho, like this, and this is the angle phi. Now from this we can write the z as rho cos phi, or as rho sin phi, and theta as unchanged 1. So these are the final expressions that relates cylindrical coordinates with spherical polar coordinates. And these are the final relationships between rectangular and cylindrical, rectangular and spherical, and cylindrical and spherical coordinate systems. So now here we have to remember few things about these coordinates, that the rectangular coordinates or linear coordinates x, y, z and r, they can extend from minus infinity to plus infinity. And here in spherical coordinate system, the position coordinate rho can be always positive, and theta can extend its value from 0 to 2 pi, and phi can be in between 0 and pi. Even in the relationships between cylindrical and spherical polar coordinates, the ranges will be the same. Means the position r can take any value between minus infinity to plus infinity, and the azimuthal angle theta can be between 0 to 2 pi, and phi can be between 0 and pi, and rho is always positive. Here theta can also be known as azimuthal angle and phi as polar angle. So that's all for this session. And so far we have completed the relationship between different types of coordinate systems. And in next session we can discuss how to solve different types of problems related to the concepts that we have discussed so far. Thanks for your attention. If you like the video, share it and subscribe the channel if you have not yet done. Thank you.